Imagine a mechanical wall of solid steel erupting from the ocean floor, violent, unstoppable, built for one purpose: to stop a Category 5 hurricane dead in its tracks. You're staring straight at a 40-foot wall of black, crushing water, and the only thing standing between millions of lives and total devastation is a barrier forged by human hands. This isn't science fiction. This is one of the most intense, high-stakes battles ever fought between human engineering and the raw, unforgiving power of the sea. Welcome back to Impossible Builds. I'm genuinely glad you're here, because today we're diving into a project that doesn't just bend the rules of nature, it rewrites them. We're heading to the coast of Japan. For centuries, this island nation has taken hit after hit from relentless typhoons. Storms so powerful they can shut down entire cities and rack up hundreds of billions in damage. Entire coastlines have been reshaped overnight, ports destroyed, homes erased, economies shaken in a matter of hours. And yet, every time, the ocean comes back stronger. But at some point, engineers made a decision: no more running. Instead, they chose to fight back. Not with warnings, not with evacuations, but with a $400 billion mechanical fortress carved directly into the ocean floor.
$400 billion. That is the price tag for standing our ground against the Pacific. This isn't a wall, it's a total reimagining of the Japanese coastline.
Today, we're not just pouring concrete. We're stepping into a full-scale underground war against the Pacific Ocean itself. So grab a snack, settle in, and let's break down how human ambition took on the most extreme environment on Earth, step by step. To build something this massive in the middle of the ocean, your first enemy isn't the water, it's the ground beneath it. You can't just drop a steel wall onto soft seabed mud. The first major storm would rip it right out like it was never there, like trying to plant a skyscraper on quicksand.
You can't build on mud. We're moving 10,000 tons of seabed every hour just to reach the bedrock.
So engineers bring in something massive: the heavy cutter suction dredger. Picture a ship that's part industrial blender, part vacuum system. Its rotating cutter head chews through the ocean floor, shredding sand, clay, and debris, while powerful suction pipes vacuum everything away. Its job? Tear apart the seabed and relocate it, moving tens of thousands of tons of material every single hour. It's loud, violent, and relentless. Day and night, without stopping, it transforms chaos into control. They're not just preparing the seabed, they're completely rewriting the landscape beneath the ocean. Once the unstable mud is gone, the next step is precision. Advanced sonic drills penetrate deep into the darkness, sending sound waves through layers of rock and sediment. These signals bounce back with detailed data, allowing engineers to map out solid bedrock hidden far below. In total darkness, under crushing pressure, they're searching for the only thing that matters: a foundation that will never fail. Now comes the real challenge. How do you actually build in open water with waves constantly crashing, currents pulling, and visibility near zero? You use caissons. These are gigantic hollow concrete boxes, each one weighing around 80 tons. But their size alone isn't what makes them powerful. It's how they're used. Thousands of these massive structures are carefully transported, floated into position, and then filled with sand and water to sink them with extreme precision. Piece by piece, they interlock like a puzzle, forming a continuous underwater wall. Imagine building a giant bathtub at the bottom of the ocean, while the ocean is actively trying to destroy it. But the ocean fights back in another way. Salt water isn't passive, it's corrosive. It eats through steel slowly but relentlessly, weakening structures from the inside out. Left unchecked, it would destroy this entire system in a matter of years. So engineers deploy something almost invisible: yet incredibly powerful: a cathodic protection system. By running a controlled electrical current through the metal structure, they reverse the chemical reaction that causes rust. In simple terms, they force the steel to refuse corrosion. It's a silent, continuous battle happening every second. One you'll never see, but one that determines whether this structure survives for decades or collapses.
The ocean is trying to eat this wall from the inside out. We use cathodic protection, an active electrical current, to tell the steel to stop rusting.
With the base now anchored deep into the Earth's crust, it's time for the most intimidating phase of the entire build: the gates. And these aren't gates like anything you've ever seen. Each one is a towering steel barricade, stretching 65 meters wide and weighing around 3,000 tons. To put that into perspective, a single gate weighs more than an entire naval destroyer. Moving something like that isn't just difficult, it borders on impossible.
Look at this. This single gate weighs more than a naval destroyer. To move something this massive with millimeter precision, it's unbelievable.
So they don't lift them. Instead, they build them on land, where precision is easier to control. Then, using massive transport barges, they float these giants out into open water. Guided by teams of engineers, sensors, and GPS systems, each gate is slowly maneuvered into position. One wrong move, and billions of dollars of equipment could be lost instantly.
These 80-ton concrete boxes are effectively the anchors of the world. Once they're filled with sand and sunken.
But here's where things go from impressive to almost unbelievable. This wall can't stay closed. If it did, it would choke global shipping routes, disrupt trade, and cripple economies. So the entire system must remain hidden and inactive most of the time, only rising when absolutely necessary. To make that happen, engineers install enormous hydraulic rams. These machines are capable of generating mind-bending levels of force, enough to move thousands of tons of steel against the full pressure of the ocean. When activated, hydraulics and compressed air work together in perfect synchronization. Slowly at first, then with unstoppable momentum, the gates rise. And when they lock into place, they form a seamless, unbreakable barrier. And just when you think that's enough, there's another problem. Japan sits on one of the most seismically active regions on Earth. The ground beneath this entire structure is constantly shifting. Even a minor earthquake could place enormous stress on rigid materials. A major one? It could snap steel like a twig. So instead of resisting earthquakes, the structure adapts to them. Massive seismic dampers, essentially giant shock absorbers, are integrated into the foundation and gate systems. Originally designed for skyscrapers, these have been scaled up to an entirely different level. Each one can handle hundreds of tons of force, absorbing vibrations and redistributing energy throughout the structure. The result? The entire fortress can flex, sway, and move, absorbing the violence of an earthquake, while still holding back the ocean. It's not rigid, it's alive.
A rigid wall would snap like a toothpick during a tremor. These dampers allow the entire fortress to flex.
But even a structure this powerful needs something more. It needs a brain. Deep underground, far from the chaos of the surface, engineers construct a hardened command center. This is the nerve center of the entire operation. Reinforced walls, isolated systems, and fail-safes ensure it remains operational under any condition. Inside, a dense network of fiber optic cables transmits data at near light speeds. Advanced AI systems process this information in real time, tracking wave patterns, atmospheric pressure, wind speeds, and ocean temperatures. Every second, the system learns, adapts, predicts. It can detect a typhoon forming hundreds of miles away, long before satellites raise alarms. It calculates trajectory, intensity, and timing with terrifying accuracy.
Our AI isn't just reacting, it's predicting. It maps the thermal energy of the Pacific to spot a typhoon 3 days before the first cloud even forms.
It doesn't wait for disaster, it prepares for it. And then there's the final challenge: power. If the grid goes down during a storm, everything fails. The gates don't rise, the system shuts down, and millions of lives are suddenly at risk. So the engineers eliminate that risk completely. The shield powers itself using a next-generation small modular nuclear reactor. Buried deep underground in reinforced containment, it delivers a constant, stable flow of energy. No dependence on external infrastructure, no interruptions, no weaknesses. It can run for decades without refueling. Silent, reliable, unstoppable.
Total autonomy. This small modular reactor can power the entire shield for 30 years without a single refuel.
And then the moment arrives. The sky turns black. The wind howls. Sirens scream across the coastline as people rush to safety. Out at sea, a Category 5 typhoon churns violently, pushing a 40-foot wall of water toward land. Inside the bunker, the system confirms the threat.
This bunker is the nerve center. It's built on isolated rubber mounts to survive a magnitude 9 earthquake.
The sequence begins. Hydraulic rams awaken, converting raw energy into overwhelming mechanical force. The ocean surface begins to churn and boil as something massive starts to rise from below. The gates. One by one, these 3,000-ton giants break through the surface, water cascading off their steel faces. Slowly, deliberately, they rise into position. Then, boom, they lock together. A complete seal. Moments later, the ocean strikes. The impact is explosive. Water crashes against steel with unimaginable force. The structure groans under pressure, but it holds. The dampers flex. The foundation grips deeper. Every system engages at once. And behind that wall, silence. Calm streets. Dry ground. A city completely untouched by the chaos just meters away.
Nature spent millions of years perfecting the typhoon. But in just 1 decade, we built the answer.
For years, people said controlling the ocean was impossible. But progress has never been about playing it safe. It's about pushing limits of physics, of materials, of imagination. This isn't just a wall, it's a statement. A declaration that even the most violent forces on Earth can be challenged and held back. A promise that survival isn't left to chance, it can be engineered. Thank you for being here and exploring this incredible project with me. Now I want to hear from you. What extreme mega project should we break down next? And where should we go? Drop your wildest ideas in the comments. I read every single one, and yours could be featured in the next episode. If you enjoy seeing how the impossible becomes real, hit that like button and subscribe to Impossible Builds so you don't miss what's coming next. Stay curious, keep building, and I'll see you in the next one.